I came
I charged him for like 2 days. I just fucking him and left him.
You want to see?
So I forgot. I was like, oh.
All right.
Why did you make that noise?
Because haha, it's not dead.
Ha ha, it's not dead.
Yeah.
Okay.
Can I wait? Let's just see how. What's that, Leon? What's that?
Just left it in the front.
What's that? You think it's dead again? You said 57%?
We're just gonna go live in like 2 minutes.
No, it's not. I have a new computer.
See, I don't think that matters.
Yes, it does. This one is like
It's not the computer.
it's indestructible.
Yeah, famous last words there.
Now it's gonna blow up.
Yeah.
When does this trimester end?
The trimester ends the last week of February, the first week of March, I believe, somewhere in that area. March 1st is the end of it. Yes.
I
That's-
cannot do AP
That's
World.
real.
So,
Yes, that is me.
Oh no,
That's
I'm
why it's
tired
my
of AP
background.
US.
so
Oh my god.
Why is that?
okay, ladies and gentlemen.
But it's okay.
So, just a reminder before break, we were talking about graphing. Actually, we made suckers right before break. The day before that, we were talking about graphing. Okay. So today we're going to do a lab activity where we are going to graph some. We're going to graph some information, put it into a graph, create a graph, and then finish up a lab with it. Okay. Just a couple of reminders. Again, I do believe that almost everybody in here. I know you're not missing any tests. We're all caught up on those. I don't believe anybody is missing any quizzes. The only thing you might be missing that actually counts for your grade are possibly labs from the first unit. So if you are missing those, please take a moment. Please find those in Google Classroom after you look at Infinite Campus to see if you're missing them and get them done. You should be able to get them all completed, ladies and gentlemen, because there's nothing in there that you should not be able to get done because, again, you were either here for it or I put in an alternate assignment. If you don't feel that's the case, please let me know. But again, let's get those things turned in because, as you said, basically we've got 2 months until the end of this trimester. So March 1st is the end of the trimester for us. And actually this month is always weird because we just get back from break. We have a couple weeks of class, and then you guys have like 2 weeks where you only have like 6 or 7 days of school. So keep that in mind. Good morning. Okay. All right. So before we get to our question of the day, anybody do anything cool over break that they want to share with everybody? I did not.
I didn't either.
I didn't come to this class.
You didn't come to this class. That's cool. That's good because you'd had a hard time getting into the building. Okay.
Maybe.
But anyone do anything exciting? No.
I really slept around with it.
Unless you count what?
Working.
I didn't do any of that over Christmas break.
I hope not.
Well, I did. I ended up working on notes for a unit later on. But anyway, so no. Okay. That's good. It's always good to have 5, 6, 7, 8, 9 days off and have nothing exciting to report when you come back.
for Christmas?
What did I get for Christmas? You're looking at it.
That's it.
That's including. That's it.
No, I got
See, this is-
radio too, and
radio?
yeah. What's wrong with the radio?
No.
You say that like he isn't
You say that like it's a bad thing.
Like, who wants a radio for Christmas?
I did. I wanted a work site radio.
He doesn't look like the type to want a radio.
So that I have one in my garage, so that when I'm in my garage doing things, I can listen to music.
We did this on paper.
What?
That's why you
do
get,
a radio.
My wife.
Wow.
So.
that's why you use a speaker.
Well, that's what it is. It's basically a speaker that hooks up to your phone, but it also has the capability of being a radio too. Is that better then?
Yeah.
Okay. All right.
So
So.
it's like a radio, like a launch radio.
No, I actually threw out the radio that was in my garage because I got this. So. Other than that, no, nothing exciting. So what?
What did you get your wife for Christmas?
What did I get my wife for Christmas? I got her clothes, new boots that she wanted, and then something to hold her wine. So that way she can't whine about nothing to hold her wine anymore. So, okay. Anybody else get anything exciting? Any new cars, trips to foreign places,
Well, I get
things?
to go to Dubai on my birthday,
Really?
Oh,
When's your birthday?
April 9th.
April, and you're going to Dubai?
Yeah.
Holy cow. Okay.
I don't
Okay.
think
Literally got nothing.
I got to go to the west side of Green Bay a couple times, but that was about it. Okay. Okay.
Okay.
I definitely can.
I got
on my
3
birthday.
duplicate vinyls.
My birthday's.
You got 3 duplicate what?
Go to like Red Lobster.
Vinyls? You have a vinyl record
Go
player?
to Applebee's. Like,
It's like.
And you got 3 of the same record?
yeah.
I hope you really like that record.
That's top tier.
They took it back and
Olive Garden.
Okay. Okay.
Oh my god.
All right. How many of you had a gift that you had to return at Christmas? Anybody?
I'm thinking about it because my grandma got me like an end table. I don't know why.
Maybe.
Your
I didn't
grandma
ask for
got
an
you
end
an
table.
end table? That's a
I
very
didn't ask
unusual
for it.
gift.
She just was like, "Oh, here's your present," and then all I asked for is money or candy, and then she gave me an end table. And
Maybe she
gave,
thought you were going to use the money to go buy an end
she
table.
gave Levi my favorite candies and like $20, but all of that together was like $40 worth of stuff spent on him. And I got an end table.
It was
I was
probably
like-
worth like
I
60.
was like, I don't want an end
The
table.
table was probably pretty expensive.
I don't. Where am I supposed to put it?
At the end.
Remember,
At the
it's
end.
the thought that counts, not the gift itself.
But she's
End
insane.
tables normally
She's
go in a
insane.
family room, not often
We
in a
already
bedroom.
have end tables.
Does it match the others?
No, not
Okay.
at all. Why do I have this?
My grandma gave me.
Well, look at it this way. Maybe it's a message that it's time to move out.
Yep.
Just
She
saying.
also
You're getting
gave
kicked
my
out.
parents end tables.
She gave them end tables?
Yes.
Does it match the one she gave your parents?
No.
Oh.
She
okay.
gave
You're
all
getting
of us
kicked out.
different
So
end
she
tables.
apparently got a discount on end tables for Christmas. Did she go to End Tables R Us?
No, it was just at Walmart.
You have to put it together.
My grandma gave me.
You have to put it
dolls
together.
for the
It's like-
USSR.
Why did I get
Well,
this?
that's where Russian nesting dolls should come from, is the USSR,
She's
because
like,
they're
look,
Russian.
LED lights.
It has a sticker on the bottom that says USSR.
At least it has
Okay.
It's old.
That's old.
Well, those are called antiquities then.
Probably. I don't know what's going on. I don't want.
I don't either.
I'm
It's,
scared to break.
I would be afraid to break them too. They're probably worth some money.
Oh my gosh.
So,
Is his present? Please. Don't go through all the.
I don't think
trouble
Levi
to
wants
get
an end
presents.
table.
yeah, Levi wasn't going for that. He wasn't going for the old trade.
Well, because that's just rude to trade lessons. I'm gonna give
In
you
front
an
of the
end
person,
table.
yeah.
Yeah, you wait a couple months and then do it when they're, But the problem is Levi's going to have eaten all the candy and spent all the money by then. So she's really in trouble. So,
You just gotta wait like
all right.
until tomorrow.
Again, it's always great to have these conversations saved for posterity on YouTube someday, ladies and gentlemen. So let's hope your grandma Brinley doesn't go to our YouTube feed and watch class for today.
I think she's.
That'd be a bad thing.
Just talk about our end table.
All right. How do we find the density of an object?
That's the point.
Mass divided by volume. Okay? So today's activity, you're going to find the density of a series of objects. Each of you is going to find the series of a different object as well. So don't be surprised when you're in the lab and your masses do not match anybody else's masses. That is absolutely fine. So let's take a look at what we got here, ladies and gentlemen. So I will be able to find the density of various objects by graphing them. We're actually going to find the density 2 ways today. We're going to find density by average, and we're going to find density by graphing. Okay? So, the graph and everything is online. The whole lab is due tomorrow, ladies and gentlemen. And again, we've been through this other stuff about our reminders that you need to get things turned in if they're missing. So, in Google Classroom, ladies and gentlemen, we go to classwork. There is the density lab. There are 2 files with it, so please open both of them up. One is the graph, and one is the document. So one is a Google Sheet, one is a Google Doc. The graph looks like this, ladies and gentlemen. The Google Sheet looks like this. Okay? What's it?
Looks like what?
Oh, shoot. Sorry.
Mm.
Yeah, new year, first time I messed that up. Okay. All right. Density is found by taking an object's mass divided by its volume. In this lab, we will find the density of a series of objects in 2 ways, then use that information to compare to a known value of the object's density. So we're not only trying to find density here, but we're trying to see how close we come to finding the actual density of an object. Okay? So at the lab stations in the back, ladies and gentlemen, there is equipment set out. Our balances, as always, are out. There are 2 different size graduated cylinders back there, and then there is this plastic tube which contains 4 objects in it. Now, all 4 of these objects are the same material, ladies and gentlemen, but they are 4 different sizes. So for this lab, we have just taken and talk about them as being the smallest, the largest, the second largest, and the third largest. Okay? Now, one thing that is very important when you go in the back, okay, where it says my sample color was, you need to, on this line, put down what the color of your sample is. So like mine would be gray blocks. Yours might be red, they might be green, they might be white, they might be silver, they could be orange. But you need to put that down because that is the only way you're going to be able to know what the actual density of them was, is by writing down what color you had so that we have that information later on in the lab. Okay? So, make sure you write down the color. Then, as always, ladies and gentlemen, we will make 3 to 4 observations that are qualitative. So again, no numbers, what you see, what you feel, you can smell, probably not going to hear anything, they shouldn't be talking to you, and please do not lick them, okay? Only because they've been used many times before, okay? Then you're going to find the mass of each sample, and you're going to find the volume by displacement of each sample. Now, I don't care which graduated cylinder you use. Try to find the one that is the most precise. Also, though, make sure that your objects will fit in them. If it will not fit in them, it doesn't make sense for you to use it. Okay? And again, ladies and gentlemen, a good rule is when you use a graduated cylinder, make sure you fill it up about halfway. Then put the object in there. If you don't fill it up very much, you may not get the object totally underwater. If you fill it up too much, you may go above the scale and then not be able to read what the new volume is. So please make sure that when you are doing this, you're using about half the graduated cylinder full of water. Now, I will tell you, ladies and gentlemen, that there is a difference between these in that how much space there is between the marks. More space between the marks makes it easier for you to estimate where it is. But it is your choice whichever one of these you will be using. When you are using them, though, please make sure you're reporting your answer to the proper number of sig figs. Digital balance, it's easy. Write down the exact number that is shown on the digital balance. In here, you're going to write down a number for how much original water you had in. You're going to put the object in there, and then you're going to write down the new answer, how much it went up, and you are going to have to subtract them. Now, I don't make you put that into the table here. You can do that either on your own, or if you want to put the numbers in here, it went 38 milliliters minus the 25 initially equals 13, whatever. I don't care. I just need you to put them in here. If you need scratch paper to do this at your station because you can't remember what the original volume was, please feel free to grab a piece when you go back there to do it. And you can write down what the original volume in the cylinder was, what the new volume is, subtract them to get your final answer. But again, remember, these need to be in the correct number of sig figs. Unit is up above here. You do not need to put units by these. Okay? Now, there is a reason that we do that. We are eventually going to graph this material. If you put letters in with a measurement, with a number, Google Sheets, Microsoft Excel will not be able to graph it. It can only graph numbers. It cannot graph words. It cannot graph letters. Okay? So again, we put the unit up above here so you don't have to worry about it here. Okay? So this is where you will collect the data while you are doing the lab. Questions? So lab, there isn't a lot to do other than find the masses and volumes and take 3 to 4 observations of your substance. Okay? Now, the second attachment is this. Same table basically, Volume first, mass second. Why? We want volume to be on the x-axis. We want mass to be on the y-axis. Explain why later. Smallest rod, third largest, second largest, largest. Please put them in order. Okay? Put them in order. Now, please think about this. If this is the smallest, what's that mean for your volume? It's going to be the smallest. I've had people do this, and their masses go up, 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 up. Their volumes go up, down, Huh? Think about your numbers. Well, oh, maybe I made a mistake subtracting. Yeah, I think you did, because there's no way the mass can get larger and the volume not get larger. So please make sure you're checking your numbers. Please make sure your numbers make sense. When you put your numbers in here, ladies and gentlemen, in this table, they will automatically then be graphed on this chart. Now, there's nothing there now because there are no numbers in here. Once you put your numbers in here, you will get a graph. Now, the important things for a graph that we need to do, we need to put a title. Title is what are your two variables. We need to label the x and the y-axis with labels and units. All of that information, ladies and gentlemen, is right here. Here's your label, here's your unit, here's your label, here's your unit. Okay? Now, we are also going to have to put in a trend line eventually. I will show you how to do that after we get everything collected before we leave class today. Okay? So after you get the numbers into your lab here, you're going to take them and you're going to put them into this table as well. That'll allow us to get the graph. Why? Because then in our lab, we're going to bring in that table from the Google Sheets into here. We're going to import it into here. We're also going to import the graph into here. We will show you how to do that either individually or as a class, depending on how quickly you guys get done. Okay? But again, remember, you need to change the title, the labels and units on the axis, and then we need to put a best fit or a trend line in there. And I will show you how to do that if you do not know how. After that, ladies and gentlemen, we are going to do this as well. You are going to find the density another way by simply taking the mass divided by the volume for each of our samples. So for our smallest sample, you found the mass, you found the volume, you're going to divide it. Give me a number here. Now again, this number on the top has how many sig figs here? 4. This number on the bottom has 2. So how many would your answer have? 2 for your answer. So if you're asking me how many sig figs, what I'm telling you, this number is going to limit your sig figs. The number on the bottom is going to limit your sig figs. This number will be 4 or 5 sig figs, depending on the mass of the sample. If it's over 10 grams, this will be 5 sig figs. If it's under 10 grams, it will be 4. If the volume is under 10 milliliters, you're going to be at 2 sig figs here. If your volume is over 10 milliliters, you're going to be at 3. So understand, some of these may be to 2 sig figs, some of these may be to 3. But you're going to find what the density of each of these is. And then, ladies and gentlemen, you are going to find the average of these 4 numbers. So you're going to add up all 4 of these numbers when you get them and divide by 4. Okay? That is how we find an average. And please remember, an average always needs to be between what 2 values? The highest and lowest. Sometimes people put these numbers into their calculator and they make a calculation error because their calculator does order of operations. Please make sure the number that you get here is somewhere between the lowest number here and the highest. These numbers should be close. These are all the same material. So they should be close. I don't guarantee you that they will be exactly the same. Okay? All right. Then we got some questions. What were the 2 ways that we determined the series, what were the 2 ways we determined the series of objects' density in this activity? So the 2 ways that we did it. In the graph, what tells us the object's density? And we will talk about that when we make our graphs. What would a property like density, why would a property, sorry ladies and gentlemen, apparently I can't talk today. Why would a property like density be more helpful than in identifying a substance rather than a property like color? Give me some reason there. And based on the table below and the evidence in the lab, what kind of material your group used in this, tell what kind of material your group used in this experiment and use data to support your decision. So again, we wrote down the color of our sample. Okay, mine was gray. So I would expect my densities to be around 1.37. That is what the known density of this material in front of you is. Here are the known densities of the materials that you have in the back. So if you have the red opaque sample, you're expecting a density of 0.9. If you have the yellow material, you're expecting a density of 1.23. So we know what you're supposed to get. You're going to compare it to what your numbers actually were in the lab. Questions? Okay. So the important thing right away is to get your sample observations made, collect your data, get your data into the graph. Call me over if you need help graphing the best fit straight line. Okay? Those are the things that we need to get done today. There's 16 of you here, so that should be 8 groups of 2. That would be the easiest thing for you to do. But I have 9 stations set up. The 8 in the back of the room and the one right behind Leaf there is set up. Okay? Get done what you need to get done, ladies and gentlemen. Let's go, let's go, let's go. Panicking is my job.
Hey, we were pretty close. We were probably excited.
Well, we were.
Okay. All right.
Oh, wait, did you want us to go to 3 figs for the average?
Well, again, we're going to talk about that right now, too, so that way we get this all done. Okay? The main thing is I just want everybody's attention so that I don't have to keep going back from group to group to group to group. Okay. On this table, I'm sorry, I left numbers filled in here for you. Please take the numbers out that were in here and make them your own. Now, hopefully you noticed when you type the number into the milliliters, to the volume, what did it automatically do to your number? What did your number end in? 0.0. Or it ended in the tenths place. If you typed in 5.2, it would leave at 5.2. But every one of these measurements here, ladies and gentlemen, every one of these should have been to the tenths place. It didn't matter which one of these 2 instruments you used. They both read to the tenths place because they are marked out in the ones place. Here, this one goes to 50, but between 30 and 40, there's 31, 32, 33, all the way to 39. Same is true here. The advantage of using this one, ladies and gentlemen, and I'm not saying you had to, but the advantage of it is these lines are a little bit more spaced out, which means you could more easily estimate the last digit of your number. So maybe the line didn't come out at exactly 30. Maybe it came out at 30.1 or 30.1 or 30.2. A little bit over the line. That's a little bit easier to see on this instrument than this one. But they both should have been to the tenths place for all of your volumes. Now again, Levi asked the question, 3 or 4 sig figs when we're calculating density. We will get to that in just a minute. But it really depends on what the volumes are here. If your volume was under 10 milliliters, you're only getting 2 sig figs then. 5.0, 7.0, 9 something like that. If it was over 10, now you're getting 3 sig figs here. 10.0, 10.2, 13.3, something like that. This number had at least 4, if not 5 sig figs. But again, it depended. If this number was less than 10, you only had 4 sig figs here. 7.300, something like that. If it was over 10, then you had 5 sig figs. That changes the number of sig figs that can be in your answer. Okay? We'll get to that. So does everyone have these numbers in here? Is there anyone who needs more time to put your numbers into here? Okay.
Updating.
How do you update it? Great question. So here's what happens. In your Google Doc, okay, now first of all, if you made any changes, say I do this, you have to hit enter to finish your changes, okay? Now, when you do that, you go back into your document, into where your graph is or your table is, and if you click on the table, there will be an update button in the upper corner. So let me bring something over here to help you, and I will show you that.
So if you updated the doc, or like just
If you updated the graph, or the data table, there should be an update button. Hang on one second. So, okay. So we'll see if I have it in here. Okay. Way too far. So here was my data table. I just made one up. Okay. Here is where it is here. So let's say I change this. I accidentally put in 50 instead of 5, right?
What if you edit the doc instead of the sheet?
Well, what I'm saying is when you go here and you click in the table that is in the Google Docs, it should say update like this. And when you hit it, any changes that you made since you brought it in will now come through. So you'll notice mine went to 50 now because that was the last change I made. So if you make changes to either this part here or to the graph in Google Sheets, when you go back in the doc, it should ask you if you want to update. Okay? That should come up automatically if you make any changes. Okay? But you have to go into the actual table in Google Docs, and then that update button will pop up. Okay? So I'm going to go back and I'm going to correct this in Google Sheet because that is where the table comes from. So here's where I switched this to 50 just a second ago on here. I'm going to put this back to 5. But again, I have to hit enter, otherwise those changes aren't like official yet, if you will. Now when I go back into here, you'll notice I got the update button again up here because I'm in the table. When I hit update, it will now change that back to 5.0. You do not have to re-copy and paste and bring your table back in. Okay? Questions? Now, the other thing that I asked you to do is on your chart, on your table here, I already have the best fit line in here for you. We'll talk about that in just a moment. But you need to change the X, the Y, and the title. Okay? Now, again, if you're not sure what goes on the X and what goes on the Y, go back to the Google Sheet down at the bottom. By the way, I'm sorry, I should have said this. I went to chart 1 at the bottom here. Here is the data table, sheet 1. Here is the graph, chart 1. Okay? So, in sheet 1, okay, I have these reversed on yours, don't I? Okay, and that's fine. Volume should be first on yours. My bad. Volume should be first, mass should be second. We did that for a reason. We'll get to that in just a moment. Okay? So, volume is first. This is what goes on the x-axis. There is the unit. This is what goes on the y-axis. There is the unit. Yours is correct. Mine is incorrect. Okay? Yours is correct, mine is incorrect. Okay? Oh, welcome back, sir. So, in here, ladies and gentlemen, okay, when you get to the chart, this is how you determine what goes on the X and the Y axis. What the labels are up here. The first column, obviously the objects are the first column, but the first column of data, that is what goes on the X axis. The Y axis is the other, and your title should be what is on the X axis versus the Y axis. Okay? That is what should be on there. Questions?
Do we put the units on the x-axis and y-axis? It says label units.
Right. So you need to label mass, volume, and then you need to tell us what unit it is because we need to know what these numbers are representing. Are they representing grams, kilograms, pounds, ounces? So you should put the label, the unit in as well as the label. The label is what the measurement was. The unit is what unit you were measuring. So you want both. Okay? You want both. Questions? All right. Now, here is the important thing, ladies and gentlemen. I also, on here for you, have this formula that should be showing at the top. Does everyone have this formula at the top? Up here.
It's different.
I know the formulas are different, but you have it, correct? Okay. What is this formula right here? What is it actually? Y equals mx plus b. Okay? Now, what is m? Slope. What is slope? Rise over run, the rate of change. I don't care how you want to say it, but it's rise over run, correct? What's on the rise axis in our graph? Mass. What is on the run axis in our graph? What is that? That is density. This is one of the ways that we are finding density in this lab. We are graphing the material. Because all of these are the same exact substance, we should be able to graph it and get an answer. Now, I totally understand that this object is bigger than this object. No questions, correct? This object has a certain mass. It also has a certain volume, both of which are bigger than this, correct? But if we divide the mass and the volume of this object and the mass and the volume of this object, they should be the same. Density is what is called an intensive property. An intensive property is a property that does not depend on the size of the sample. What temperature does water boil at in Celsius? 100 degrees. What temperature would a lake boil at? 100 degrees. What temperature would a cup of water boil at? It doesn't matter how much water is there. It will boil at the same exact temperature because boiling point is an intensive property. It does not depend on how much sample is there. Does mass depend on how much sample is here? Yes. This has a larger mass than this. Does volume depend on how much sample is here?
Yeah.
Yes. Those are called extensive properties. Those depend on the size of the sample. Does color depend on the size of the sample?
No, some.
What do you mean?
If it's or like translucent, then it might be like harder to see through.
Okay, but we're not talking about color there then. We're talking about being translucent, opaque, or transparent. Not the same as color.
So color doesn't depend on shade.
It can, but you can have a red stained glass that is translucent, or you could have a red glass that is opaque.
Yeah, and they're the same color.
They're the same color, but whether you're able to see through them or not is different. Okay? So it's just a little difference there. Okay? Just a little difference there. I understand what you're saying, Leaf, but again, there's just a slight difference there. Okay? So what that means, ladies and gentlemen, is it doesn't matter which of these samples we find the density of them, all of them should be the same. Because as mass is going up, volume is also going up. Okay? When we divide them, they should come out to numbers that are very close to each other, which is why in your lab, hang on a second. Let's go to this one. Down here in this part, when we ask you to find the densities here, you're going to take the smallest mass divided by the smallest volume, and you are going to get an answer. You're going to get a density. You're going to show me what that is. Okay? Now, up here, I want you to take out my numbers that are in here and show me one example with your numbers in here. So what that means, ladies and gentlemen, is you can right now click on this number at the top here and change it. I double-clicked on the number at the top here, and you can change that number to one. I don't care which one, any one of your four. Change the mass there. Then click on the one at the bottom and change the volume. And show me an example of doing the calculation. What do you get when you divide the two? If you need calculators, they're up here. Come up and grab one. If you do it on your computer, I don't care. So you are going to then, after you've shown me one example, after you've shown me how you're doing this, this should be one of these four answers down here. I don't know which one, but it should be one of them. You then do the same calculation for the other three. Take the mass divided by the volume, give me the density. Levi, you asked how many sig figs here a long time ago. Sorry, here we go back to it. How many sig figs are in this bottom number determines how many sig figs are in these answers.
I meant the average.
The average, how many sig figs in these numbers? The smallest amount is what your average can be in.
Because your material example had more.
I understand that, but my material example was calculated using different things.
Okay.
So therefore, again, when you look a value up and it gives you a different number of sig figs, that just means that the instruments they used to take those measurements were more precise than the instruments we are using here. Okay? So again, we have to go with our measurements on what we did. But you're right. A lot of times you'll look things up and there'll be more sig figs or possibly less. That's because it depends on what instruments they used. Fair enough? But you're still comparing it. So, okay, what do we get for a density here? What number do you get here? And then how does it compare to the one down here? So if you had that yellow material, did you get close to 1.23? Now your sig figs may only be 1.2 because you may only have 2. But how close did you get to that number? Okay? Now, sorry, I'm kind of jumping around on you, but let's go back to this. Let's go back to the right thing in the background, otherwise it doesn't make a whole lot of sense. There we go. Okay. So this number in front of the X, this 2.51 in my lab here, this number right here, that is also the density of this material. Found by graphing it, not by doing an average of them. found by graphing these 4 samples and putting in a best fit straight line. So this is another way that we can find density of a series of objects. We could take the average of all of them. Or, ladies and gentlemen, we can graph the line, and when we do, the slope of the line produces the density of the material. Okay? The slope of the line will produce the density of the material. So what units should this 2.51 be in here? What's the unit for mass? Grams. What's the unit for volume? So this, just like the calculation that you just did with average, should be in grams per milliliter. That is the same unit you will come up with, whether you did the average or whether you found the slope of the line. Okay? Now, you'll notice that the B here, 0.041, very close to what number? 0.41 is very close to 0. Should it be? Why? Well, what's the volume of an object with 0 mass? 0. Should be 0, 0. This should start out at 0, 0, this graph. Because when you have no volume, you have no mass. So again, good data here. Okay? Good data here. So that is why we put this graph in there. Does everybody know how to put the graph into their lab? Is there anyone who needs help putting the graph into the document? Okay. So here's what you're going to do, ladies and gentlemen. Let me get out of here. Now, you have multiple ways of doing this. You can go to your chart. You can copy the chart. Go into your lab. Here where it says insert the graph, you can then do Control V and it will paste it in there for you. That is the easiest way. So you can put it in that way. Copy chart. Go into your document to the place that you want it. Control V will put it in there. The second way that you could do it, ladies and gentlemen, is you could do insert, chart from sheets. You can find yours. Now, it will be the top one that you are working on. Because I have access to all of yours, it is not the top one for me. But I'm going to insert Najma's anyway. Click on it twice. So I click on my file twice. I understand that, but she's giving me permission and I'm giving her credit for it. I am not claiming it as my own work. Therefore, it is not plagiarism. Highlight it and import. Now, look at those 2 graphs, ladies and gentlemen.
Wow.
Which one is a lot clearer?
The bottom.
I don't know why we've talked about this before. This is what happens when you do copy chart. This is what happens when you import it. I prefer this one. Okay? I prefer this one. But I don't care as long as you put it in here. So here's her formula. What was Najma's density for this material? What was your density?
1.23.
Well, according to this graph, you got 1.24.
Well,
Now, what was it supposed to be?
1.23.
Then that's pretty darn close, don't you think? Off by 100th? Now, the question is, how close, sorry, going the wrong way. How close is it to this average? Because these were the 2 ways that we found the density. We did it by graphing the material, and we did it by finding the average of 4 samples. So you're going to have a slightly different number here. Hopefully it's very close to that.
It's 1.23.
Okay, that's very close to that. Okay?
Yeah.
That's what we're saying. This is one way of finding density. The graph is another. Questions? Okay. So you need to finish a couple things before you turn this in. Number one, these questions. And we just went over all the answers to this one and the one below it. This one you have to come up with your own answer for. Which do you think is better for determining what substance this is? Using the numbers from density or using your qualitative observations that you made? Okay?
Can we say both?
If you want, but justify it.
Okay.
Justify it. And then down here, ladies and gentlemen, based on the table below, yes, the table below. Sorry, I forgot that the known values were underneath there. And the evidence from the lab, what kind of material did your group use? What was the material that you used? Was it wood? Was it acrylic? Was it aluminum? Was it PTFE? Was it polyvinyl chloride? Was it phenolic? Was it polyurethane? Which one was it? And then tell me, using data, why you picked the one you did. How the numbers that you got compared to the numbers that you were supposed to get. Gerald.
What property did you call density?
Density is an intensive property, but it's also just a physical property.
And then the other ones are extensive.
The other ones are called extensive.
And that's why it would be more helpful.
Well, here's the thing. Yes, an intensive property, because it is the same no matter the sample size, is probably more useful in identifying something than an extensive property, which changes depending on how big the sample is. You will not find a target, a known value for what the mass of this is. Okay, we can't do that. I can give you a known value for its density because its density doesn't change no matter how big it is. Questions?
8%, 20%.
Okay, so here's the scoop, ladies and gentlemen. Tomorrow when you come in, I will give you about 10 minutes to finish the lab, to finish answering the questions, to do anything you need to. If you think you need more than that time, you got to work on it tonight. If you didn't get your graph imported correctly or your data table doesn't look right or something, first 10 minutes tomorrow, I will answer any of those questions you have. I will help you with that. This is due tomorrow by the end of the day. I'm only giving you 10 minutes in class, though, to get it finished. So you will have more time than that tomorrow, but you only got 10 minutes to ask me questions or to get help on it that you may need. Questions?
You got signed out.
You're signed out.
What?
You got kicked out.
Yep, you're signed out.
I didn't do anything.
Well,